So it's going on 131 when we're done. So we're going to do the same type of thing we did yesterday, but with a calculator. And so when we are doing this, you need to make sure that you are in radian mode. Oh, goodness. So when on these calculators, when you clear them, the default is radian mode. So if you just clear the RAM before you start, it's in radian mode. You don't really have to check anything. But if you're just going to grab one, especially since I also teach geometry, when we're doing trig, we're doing it in degree mode. You want to double check it. Either just clear the RAM or double check it so that you can make sure you're in the right situation there. Okay. And so we're going to solve each trig equation on the interval from 0 to 2 pi to the nearest thousandth. How many decimal places is that? 3. Okay, 3 decimal places. And we're looking at the quadrants just like we did yesterday. We've got to make sure that we get, sometimes we have more numbers than others that we need to use more answers. And so when you find these, okay, when we have our reference angle, so your reference angle is always going to be in the first quadrant. To use this reference angle to get our angle in the second quadrant, what do we do? How do we? Because if this is my reference angle, yeah, 180 minus, so this would be pi minus alpha. To get third quadrant, it would be pi plus alpha. And then this would be 2 pi minus alpha. All right. So we're going to decide which quadrants we need, and then we go about that. Now, one of the things that because we know that this is, 0 pi halves, pi, 3 pi halves, 2 pi. But when we're looking at decimals, that isn't something necessarily that you recognize right off the bat, because we haven't used the decimals that much. We know that this is 0. We know at pi, that's like 3.14159, blah, 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 right? So pi halves is about 1.5 something. That can kind of, it's about half of 3, but it's 1.571. You'll start to recognize these a little bit more. And then this would be 4.712. And then 2 pi, 6.283. So about 1.5, about 3, about 4.7, about 6.3, just kind of have an idea so that you can think about whether or not you're in the right quadrant. All right, so we'll start with this one. We want to solve for x. So this is one where we're just getting basically the sign of x by itself. So I'll subtract 1 over here and then divide by 5. So the sign of x is equal to negative 1/5. Everybody okay with that? Which means that x is equal to the sine inverse of negative 1/5. And again, I'm okay with you not writing this step every single time. I just want to make sure you understand that that is what is happening. So what we're going to do is we're going to go and use the calculator. But even though this is a negative 1/5, we only type in and do the inverses of the positive values because that will give us our reference angle. Like this would give us one of our answers, but we need the reference angle to find all of the answers that we need. Does that make sense? So when you put this in the calculator, you use positive number in calculator. Always. So we do the sine inverse. So y'all remember how to do sine inverse, right? I got to make sure I'm probably not in radian mode. But I am now. It's hard to see this. Okay. Good. So now I'm going to do, can't even see what doing the sine inverse of 1/5. So sine inverse of 1/5. And this is what we get. This is our alpha. Okay, this is our reference angle. When you get this number, you want to store it. Okay, so we're going to store it. You can store it wherever you want. X is the easiest and makes the most sense, and we're not going to have to store multiple things at one time, so X is absolutely fine. So then what I have here, what I have found, is that my reference angle, which is alpha, is going to be 0.201 ... Okay, put ... because there's a reason that you stored it, right? You never, ever, ever go back and retype in a decimal, right? But you can write it down so you have an idea of what's going on. Then we have to figure out which quadrant we are using. Okay, so to figure that out, for sine, it's negative. Which quadrants are sine negative in? 3 and 4, right? So these are the two quadrants. So what I need to do is I need to do pi plus alpha and 2 pi minus alpha, which is your x, basically. So in your calculator, then, you just do exactly that. You can do second little caret top for pi. I'm going to do pi plus x, and then I'm going to do 2 pi minus x. And there are my two values right there. Okay. Does that make sense to you? So then in the end, my answer is a set of numbers, which would be 3.343 and 6.082. Any questions about that? And if you look at this, your number, this 3.343, which is in the third quadrant, that is between the 3.141 and the 4.7. And then your 6.082 is between these two numbers, which gives it in the fourth quadrant. Okay? We good? Kind of a way to check yourself there. Any questions? All right. So really the same thing as yesterday. You just got to make sure you know how to get how many answers and which answers you need. All right, so I've got tangent squared x equals 100. So what could I do here? I could take the square root. Could I also subtract and then factor difference of two squares? Yes, but taking the square root is way easier. So that means that would give me tangent of x is equal to what? Close. Plus or minus. Do not forget your plus or minus. It is plus or minus 10. Okay? So that means I'm looking for when tangent is positive and when tangent is negative. So I'm using all four quadrants, which means I'm going to have 4 answers in the end. Okay. So that means I'm going to get x is equal to the tangent inverse of plus or minus 10. But I only use the positive one in my calculator, right? So when I use the positive one, I'm going to get tangent inverse of 10. And 10's a big number. Remember 10, tangent's all real numbers. You can't have something that was 10 if it was sine or cosine. But get that, I'm going to get 1.471. I'm going to store it in x. And then let me write that down. So my alpha is 1.471 ... And then I need it in all 4 quadrants. Well, that is my quadrant 1 answer. So then I also need to do pi minus x, because that gives me my quadrant 2 answer. I need to do pi plus x. That gives me my quadrant 3 answer. And then 2 pi minus x gives me my quadrant 4 answer. And I can go ahead and just kind of get them all on there, and there's my 4 answers that I need. Make sure you can round correctly and you know your rounding rules. We're all big boys and girls. We should know our rounding rules by now. And so my answer then gives me 1.471, 1.670, 4.613, and 4.812. Any questions at all? Okay, if you're not getting these on the calculator or having any issues, let me know. But yeah, you can see I'll punching around, so that's good. You be punching the numbers too. Don't just be copying down what I have. All right. So now I have 5 times the cosine of x equals 2 secant of x. So what do you think we'd like to do first here? Do we need to change something? Yeah, what can we change? The secant. I would change secant. You want to get into the sine, cosine, or tangent because those are the only buttons you have on the calculator, right? Putting it all in secant doesn't do me any good. But what is the reciprocal of secant? Cosine, right? So 5 times the cosine of x is equal to 2 over the cosine of x, right? So then what can I do? Good. I want to move it over to the left. How do I move it over to the left? Multiply. Good. Get rid of that fraction. So now I'm going to get 5 cosine squared x equals 2. So then I got to get this by itself before I take my square root. So cosine squared x is equal to 2/5. So I could subtract and do difference of 2 squares, but that would be really weird here. So instead I can just do what? Square root. So I get cosine of x is equal to what? What goes first? Plus or minus the square root of 2/5. All right, now, if this was something that we were doing that was non-calculator, we would need to fix our square root, rationalize our denominator, and make it all pretty. But we're about to use the calculator, so we can just leave it in a yuckiness like this, and it's fine. That way, we don't do anything else weird. But I'm only using the positive one. I'm going to do the cosine inverse, right? And cosine, I'm looking for plus and minus. So again, I'm using all 4 quadrants, because that takes care of the positive and negative of all of it. So when I type this in, I'm going to do the cosine inverse of the square root of 2/5. So then I make sure that I close my 2/5 because that's under the square root, and then I close the whole thing. So I'm actually taking the square root of the whole 2/5 type of thing. Make sure that it's all good. I'm not just taking the square root of 2. I hit enter. So my alpha is 0.886 ... I want to store it. You can store it all in one step. I never ever remember to actually do that, but just so you know, when I type all this in, I could hit store in X right then and it would calculate it and store it, but I don't know that I've ever actually remembered to do that, so I always do it the long way, but you can't put it all in. All right, so that's my X, or my alpha. So then I've got to have all 4 of them. That means I need to do pi minus X, pi plus X, and 2 pi minus X. Then I make sure I round correctly so that my answers make sure that you agree with me. All right, any questions? We good? I'll take that as a yes. All right, the next one. Well, I don't see that I can factor out a GCF. I don't see that I can just like take the square root of both sides, so I'm going to have to factor. Now, I did see that some of y'all were actually using that U substitution. How many of you are actually using that and feel like it's kind of helpful? Anybody? Is it better than looking at it as secant and trying to think weird things? I kind of think so, and I kind of think that if you kind of got used to it now when things aren't super crazy weird, that when it did get super crazy weird in calculus and you're like really supposed to use it, it won't really be that big of a deal. So I'm not going to make you use it, but I do think it can be helpful. So I'm just going to say U is equal to the secant of X. So this gives me, I'm writing secant again. I think it also might help you see patterns a little bit better. And then you won't have to work so hard. Okay. Is this a special case? And if you don't recognize it as a special case, that's okay. But it is. It's a perfect square trinomial, right? If I can take half of this and square it and get this number, then I don't have to necessarily factor it the long way. Right? This really is just U plus 3 squared equals 0, right? And you're way more likely to recognize those things if it has a U in it and not the crazy secant stuff. But again, if you don't recognize that, you just have to factor it, and you can get the same thing anyway. They'll just be next to each other. So even though there's 2 factors, they're the same, so there's really just 1. So what I have here is secant X plus 3 squared equals 0. So once I factor it, just like I would if it was just some boring old quadratic we're used to, is you take each factor and set it equal to 0, but again, you only have to do it once. So secant of X plus 3 equals 0. Oh, I should also point out, at the beginning, I could have changed it to cosine at the beginning, but that would have made things a lot yuckier, right? I wouldn't trade things out until the end unless it was something like the other one we did where we kind of needed to do it to be able to do anything with it. Okay, so just not get too weird there. So that means that secant X is equal to negative 3. All right, well, again, I don't have a secant button on my calculator. But I know that the reciprocal of secant is what? Cosine. So if the secant of x is negative 3, then the cosine of x is what? Negative 1/3. And it's that easy. You don't have to do any work to get it to that point. Okay? So I'm going to give you a second. I want you to get your numbers there. Get your answers. How many answers are you going to get? You finish it up and then see if we match and if we agree. How do I know which two I want? When cosine is negative. And cosine is negative in the second and third quadrant. So my alpha isn't one of my answers because that's my first quadrant answer. So I only need pi minus alpha and pi plus alpha. Okay. Well, good? Any questions? Awesome. All right. Moving on. Okay. So I've got a cosine and a sine. Neither one of them are squared, so I can't do the Pythagorean identity thing or anything. So what would I do in this case? Do what? I heard something over there. Okay, divide them both by cosine. How does that help me? Becomes tangent. Very good. Let's see what's right. Okay, so those cancel out. But remember, we're not canceling out on both sides because that's not legal at all. But we get 4 equals negative 7. Instead of sine over cosine, that gives me tangent of x. So that means that tangent x is equal to negative 4/7. Or 4 over negative 7, it's the same thing. And it's okay to leave the tangent of x on the right. I think I was just probably trained and bullied into always making my x on the left. I can't help myself. So even though this is negative, do I take the tangent inverse of a negative 4/7? No. Do the positive one. Let's go ahead and take care of that. Let's get our alpha. We good? Y'all agree with me? Yeah? You got something different? Did everybody get something different? Dang it. Okay. Maybe I did this wrong. I just typed it this in quickly this morning. Crap. Oh, what did I do? I just did pi plus x, I guess, probably is what I did. Okay, that's what I did. I did the wrong one. Okay. Go good. The whole thing wasn't wrong. That makes me feel better. Whew, I was a little worried there for a second. Okay, so I need to do, all right, just tell me what it is, because now I don't have to type in my calculator right. What'd y'all get? 764. Okay, good. Yeah, at least we'll agree. Yeah, I totally did the wrong thing. I had the right quadrants checked and everything. I just typed it in wrong. See if you're paying attention. See if you were really working it out. Good job. Okay. All right, everybody good? Awesome. All right. Now let's look at the next one. So on this one, can I divide both sides by secant? No, because that's the whole canceling out where I actually lose a root. Okay, it's different than the dividing and the one right above it. But these two factors do have something in common. So I need to actually factor it. So that means I need to move everything over and set it equal to 0. So 3 times sine x secant x minus secant x is equal to 0. Then can I proceed? Yes? What can I do? Factor out. Good. I'm going to factor out the secant x. You get 3 sine x minus 1 equals 0. So then I take my two factors and I set them both equal to 0. So secant x equals 0 and 3 sine x minus 1 equals 0. So now I have sine of x equals 1/3. And then I have this secant x equals 0. What is secant the reciprocal of? Cosine. So can I take the reciprocal of anything and get 0? Is that even possible? Think about that. There's not a reciprocal of anything that gives me 0. Take out that, find that white paper, I don't have it to put up here, that had the parent functions on it. And it had the had all 6 of the parent functions on it, and then it had the inverse parent functions on it. I gave it to you, the graphs, yeah, probably page 126-ish. It looks like this. Sorry that I can't show you this one. I just gave it to you the other day. It was in Miss Rice's video, but y'all didn't have it, and I just gave it to you. So, because I want you to look at the graph of secant. Okay, and I probably should have had it so I could do it up here. But your cosine graph looks like this. This is going to be a very, very bad drawing of this. That's why I wanted you to look at it. So your cosine graph looks something like that, but a whole lot better, right? So secant is basically the opposite of that. It looks like this, right? But again, a whole lot better. So the green is your secant graph, right? Do you see that? And then the purple would be like your cosine graph, and these are all asymptotes. And do you see how secant is never 0? It can be. Doesn't make any sense, right? So this right here is an extraneous solution. Secant of x cannot equal 0. We didn't do anything wrong, but secant of x can't equal 0, so I don't even use that as one of my solutions. Okay? And that may happen when you factor things. It happened on the assignment you got yesterday. You'll get some where you get like cosine of x equals 2. Well, can cosine of x ever equal 2? No. Get all the 1 is the highest it can be, so you just throw that out, and we would only use this one. Okay? And we're not going to take the time to actually find it. Y'all understand how to find it and which ones to find, right? Okay, then I don't want to spend any more time doing that. Okay? Are we good? Any questions at all? Awesome.